Hello student, welcome to new video. Now we have to use the substitution method again, but in this example you will not find out other function or other terms, so that we can get the derivative of the given. We can get the derivative of the substitution in the same function. So how to do that? So first example in this is integration cos raised to 7. Now cos ka power is 7, right? Then you will ask me why we cannot use the direct formula of x raised to n. Correct na? Why can't we apply x raised to n formula here? Because x raised to n formula is applicable only when your base that x is an algebraic function. But cos is not algebraic, your cos is trigonometric function. So that's why we cannot apply x raised to n formula directly here. So here we will use substitution method. But how to use the substitution, that we will see. Okay. See, can we split this example, this cos raised to 7 like this? Cos raised to 6x into cos x. That we can do next element. Cos raised to 6 can be write like this. Cos square to the power 3. Yes, we can write. Similarly, this cos square can be write 1 minus sin square x. Then power 3 cos x like this. Now we will use substitution method here. So what substitution we can do? So here we will substitute sin x equal to t, take derivative on both sides. Sin ka derivative will be cos x dx equal to dt. So this cos x dx I can replace by dt. So how I write the function 1 minus sin square become t square bracket 2 cos x dx is nothing but dt. Now you can see your function is expressed in terms of t, right? Now you can expand this function. Okay? 1 minus t square whole bracket 2. Assume that this is 1 minus t square in the form of a minus b cube. Correct? So expand this a cube becomes, what is the a cube? A cube is 1 cube, right? Then write minus sign. Correct? Then 3 is outside, so keep outside. A square, a is 1 ka square 1, and b, what is the b? B is t square dt. Then write plus sign, then b again outside, then a is 1, what is b? B ka square means b is your t square, t ka square becomes t raised to 4 dt. And last is b cube means t square ka cube. How do you write? T square ka cube. T square ka cube is nothing but t raised to 6. Okay na? Okay? So integrate this. 1 ka integration becomes p with respect to dt minus p as t square ka integration t cube by 3 plus 3 constant. T raised to 4 ka integration t raised to 5 by 5 minus this minus as t raised to 2 ka power 3. 2 into 3 becomes 6. So t raised to 6 ka integration t raised to 7 by 7. Correct? So we have done with the integration, we add c, but don't forget to replace the value of t, because t was nothing but sin x. So write down the final answer by replacing the value of t was sin x. How do you write? Sin x minus, see this 3 will cancel, t cube becomes sin cube x minus this 3 by 5, then t raised to 5 is nothing but sin raised to 5x, then t raised to 7 by 7 means t raised to 7 means sin raised to 7x by 7 and plus c for constant. Okay, you understood this? Okay, now let's see one more example of the integration, that is example is integration of tan 3x tan 2x into tan x dx. This is the function that we have to integrate. Okay. Now let's see how to integrate. tan 3x, tan 2x into tan 2x, all these three terms are in the product form, so we cannot take their integration directly. If they are having plus or minus sign, then we can integrate them separately. But the operations given between all the three terms are dot product. They are in product form, so we cannot use direct addition or subtraction method. So what I do, this tan 3x को tan 3x को can I write tan 2x plus x, correct? If I can write like this, then can I apply tan a plus b formula? What is the tan a plus b? Tan a plus tan b divided by 1 minus tan a into tan b, correct? Then this term shift to the left side, we will multiply to our tan 3x. And your right side will be tan 2x plus tan x like this, correct? Then tan 3x multiplied to both the terms, tan 3x into 1, tan 3x minus tan 3x into this 2 will be added. So tan 3x into tan 2x into tan x is equal to tan 2x plus tan x, correct? Now this negative term when you shift to the right side, it becomes plus. First term tan 3x as it is, tan 2x and tan 2x both are positive, shift to the left, it becomes minus tan 2x minus tan x is equal to this negative tan 3x tan 2x shift to the right side, it becomes tan 3x into tan 2x into tan x. So we can see that tan 3x into tan 2x into tan x, this total function I can replace by these three new terms and I can integrate them easily. So integrate these three terms, tan 3x dx minus tan 2x dx minus tan x dx. Okay, can you tell me what is the formula or what is the integration of tan? Integration of tan was log of sec, but here not x, here it is 3, so log of 3. But don't forget to multiply by coefficient of, reciprocal of coefficient of x. X का coefficient is 3, उसका reciprocal is 1 by 3, so multiply here by 1 by 3. Similarly, coefficient of x is 2, उसका reciprocal 1 by 2, बाकी same. Here x का coefficient is 1, that is invisible, so write directly log. So this is your answer. 1 by 3 log sec 3x minus 1 by 2 log sec 2x minus log sec x plus c. Okay, you understood this both the examples. So in next video we will see few more example or new type. Okay. Hello student, welcome to new video of the integration. In this video we are going to see some special integral. It means if you cannot apply the given formula, like we have so many formulas, if you cannot apply that formula directly with the given function to find out their integration, at that time we use with this special integral. Special integral means we have some special formula. If we have some particular types of integration function, then how to integrate it, that we'll see in this point. Okay, so let's see, there are 7 special type of integral that we are going to see, and we have some example also basis on that, some special integral. So let's see that special integral first, and then we'll see how to simplify it or how to find out the integration when your function out of this type. Okay, so let's see the first one. Some special integral. The first integration 1 upon x square plus a square. Now what is a here? A will be any constant number which is given in terms of square form. If it is not given in square form, then we have to convert that into square form, and then what will be the integration? 1 upon x square plus a square का integration is 1 by a tan inverse x by a plus c. When you have your given example in this form, you can directly write out the integration is 1 by a tan inverse x by a plus c. Okay. Similarly, second is 1 upon x square minus a square dx. Now here position of x and a is changed, but here a square was positive. Now here a square is negative, right? So the integration 1 by 2a log x minus a upon x plus a. Here I have written x minus a and x plus a into modulus sign because negative value of log does not exist. Okay, plus c, every time you have to write the c. Then a square minus x square. In these two, x square was positive, but here x square is negative. So obviously the integration will also get changed. So 1 upon a square minus x square dx का integration will be 1 by 2a log a plus a upon a minus x. A plus x upon a minus x. You can see the difference between these two fractions. Okay. Then if you have this a square x square into root side. Okay, 1 upon root a square minus x square dx का integration sin inverse x by a plus c. When you have a square minus x square into root sin, their integration sin inverse x by a plus c. Similarly, second, if you have this x square minus x square into root side, 1 upon root x square minus x square dx integration is log modulus of x plus under root x square minus a square. This root x square minus x square added into modulus n. But only we have to add x before log, after log. Log x plus under root x square minus a square. Okay? Now, if you have this a square x square in the root side, okay? A square and x square both are positive, so if you change their position, that does not matter. So, root a square plus x square dx equal to log x plus under root a square plus x square. Correct? The integration is log x plus under root a square plus x square. See, x के बाद plus है, x के बाद plus है, which is common. But change this root term. This root term added here, this root term added here. Correct? Similarly, let's see. 1 upon x into root x square minus a square. We are applying x before this x square minus a square. 5th and 7th, let's see what is the difference. Root x square minus x square, but here we are applying x before root x square minus a square. So their integration 1 by a, say inverse x by a plus c. Okay, this is your some special integral and their corresponding integration. Okay, but if you see the very common term in all this formula, here x square is always in isolated form. There is no variable, there is no any constant number, or there is no any coefficient with x square. Here x square is always in isolated form. So make sure whenever you solve this type of example or whenever you solve example on the basis of this special integral, make sure your x square is always isolated. X square should not have any constant term. Then and then only you can apply this formula or this integral. Understood? Let's see one example where we have any constant number with the x square and how to get rid of that constant number and how to isolate x square. Okay, let's see one example. Integration 1 by 4x cube minus 3 dx. See, as I told you, x square should be in isolated form, right? In every formula, x square is isolated form and your a is also into square form. In every formula you have seen a square, it is given a square. Never it is a. It should be a square. Okay. So example 1 upon 4x cube minus 3. So what according to this formula